Good afternoon, everybody, and welcome to the first ever Data Champions Online Insurance. My name is Maisa Roberts. I'm a conference director and content producer here at Corinium, and I'm delighted to welcome you today. For those of you who have joined us at an in-person or online Corinium event before, welcome back. For those of you joining us for the very first time, welcome, thank you, and we hope this is the first of many. It's a real pleasure for us to be hosting this event. Last year, we ran DCO Insurance in New Jersey with our biggest ever audience, and we were excited to return again with a bigger and better event in 2020. However, as we all know, the world has changed a great deal since then. And while we hope to be back in person in the very near future, we're also very excited to virtually connect with our community of data and analytics leaders within insurance. Now, before we jump into today's fantastic content, I wanted to take a brief moment to draw your attention to a few things. First, throughout the entire event, you have the chance to win a set of Apple AirPods. All you need to do is to share a selfie of yourself tuned into today's session on LinkedIn using the hashtag DataChampionsOnline. We'll select a winner at random, and we'll be in touch about how to claim your prize. Again, simply post a selfie of you enjoying today's sessions on LinkedIn using the hashtag DataChampionsOnline for a chance to win. Now, we know that interaction is important to you all. So each session has time allocated for expert speakers to answer your questions. Using the Q&A box below, please submit your most pressing questions throughout the session, and we'll do our best to get as many answered as possible at the end. In the unlikely event that you encounter any technical issues during the session, please first refresh your browser and re-log into the system. If that doesn't work, simply drop the team a message in the Q&A box, and we'll be happy to help. Finally, you also have an array of downloadable content below, including our global online and in-person events calendar. So please download as many items as you wish to read in your own time. Now, with the housekeeping done, it's a pleasure to introduce our first speaker of the week, Chris Mansour. Chris Mansour is the Director of Data Science for Insurance, Banking, and Retail at DataRobot. He has served as an actuary and as a data science executive at Travelers and CNA, and has over 2 decades of experience in property and casualty insurance. He is a fellow of the Casualty Actuarial Society and holds a master's degree in mathematics from the University of Chicago. Chris will be sharing some key use cases for AI in insurance that go beyond pricing and underwriting, along with strategies for overcoming roadblocks to AI. Day in and day out, we hear from our insurance network about the challenges of cutting through the hype, breaking down the buzz, and deploying AI and machine learning to have a real and genuine impact in their organizations. And I'm sure it is the same for you, our audience today. I'm certain that this is going to be a very insightful session with valuable takeaways for you all. So with that, I'll put aside and hand it to Chris. Please remember to send in your questions when they come up in the Q&A box below. Chris, welcome again, and thank you so much for joining us.
Thank you, Maisa. It's an honor to give the keynote here. And hello to, I'm sure, many members of the audience. It's the one strange thing about doing this online is I can't see the audience. I'm sure there are many familiar faces there. But I figured since the audience also can't see each other, it might be a good idea to start with a couple of poll questions to get to know each other's backgrounds a little more in terms of how much analytics we've done and what aspects of insurance we've been most involved in. So I thought I would kick off the live polling at the very start. So with that, I was curious how long each of you have been doing analytics as part of your job. That'll kind of help me gear this this presentation towards who's in the audience. And Maisa, do I need to advance one more for people to be able to answer this?
Yes, I think you need to wait a bit for them to turn in. You will be able to advance it.
Yeah, let me go back here for a moment so that the folks haven't had a chance to answer. It looks like we've got a pretty experienced audience. Looks like the median is about 9 years, and I don't know how 7 to 9 got left off of there. I think I intended for that to be 4 to 9. So my apologies for not giving all of the appropriate choices. And then I was also thought it might be helpful for us to get to know each other in terms of what specialties, sorry, not what specialties, what the biggest impediment to leveraging AI is in your experience. Yeah, is it implementation difficulties? Is it lack of transparency for the users? Is it not having skilled staff to build the models? Is it not having the appropriate data, or is there some other blocker that prevents you, maybe not prevents you from building AI models, but prevents you from realizing the value from them? Good, about 10 more seconds is one people might have had to think about, unlike the previous one. So the third of the most common response was lack of skilled staff, and the second most common response was lack of data. So that's and all the responses had had a reasonable representation. I'm not too surprised. That's actually lack of skilled staff is a great lead-in to really the first thing I wanted to talk about, which is we've got a lot of demand for AI. We only have so many data scientists. Data scientist is, in many recent years, been listed as the best job in America. That tends to mean that it's there's not enough of them. They're difficult to keep happy. They tend to move around from one place to another. How do you, if you need data scientists to build machine learning solutions, to build AI solutions, how do you do that when they're expensive? How do you manage to build the solutions anyway, even if you don't have enough data scientists? And I think the solution there really is figuring out how to empower other people to do what some of the things that data scientists do. I mean, there is always a frontier. There are probably always problems that you will want data scientists doing, but those shouldn't be the same problems today that you had data scientists working on 5 or 10 years ago, and they shouldn't be the same problems in 5 or 10 years that they are today. Once something is no longer on the frontier, it should become more routine, and we need to think about how do we enable people who understand the business but don't necessarily have all of the skills that data scientists have to make that AI work, to keep those sorts of things moving. So, for example, DataRobot's product, for example, is geared towards enabling people in the business to build models that in the past data scientists might have built, and that allows data scientists to focus on difficult problems instead of the same routine problem from 5 or 10 that they were working on 5 or 10 years ago, which is probably not the best use of an expensive person's time. And also, given the nature of data scientists, they're doing the same thing for a long period of time, they're going to tend to get kind of bored and think they're not getting the professional development they need. So it's really critical to find ways to leverage, whether it's using a tool like DataRobot or some other way, to leverage more people in your organization to create AI, to create machine learning. And what are some of the challenges? And when I say the insurance industry is challenged by manual analytics, I mean the data scientists doing lots of things the same way they would have done them 10 years ago rather than more efficiently. It's really made it challenging to bring machine learning to all of the products that insurance and all the aspects of an insurance company's operations. So, for example, if you write $1 billion in premium for a particular product, or $2 billion, you're probably willing to invest a lot of money in the policy system. You're willing to invest a lot of money into implementing a brand new rating plan that the data scientists came up with. But what that does is it develops muscle memory around, gee, this stuff's expensive. You kind of develop processes for implementing AI that are expensive. And then you have other products that in some sense might be simpler, like inland marine, where there's not nearly as much premium. It's and then people say, well, we should build predictive models for inland marine. Oh, we can't. It would be too expensive. There's not the premium volume to justify it. Well, what that should be telling you is you need to find more nimble ways to acquire data, build models, and implement models, because you certainly can do AI for just about any product that you're selling. And there's also a huge change in data. So data shifting, and the events of the last couple of weeks are going to make it shift more this way, away from demographic data, which I suspect is going to become a dirty word, towards data that's actually about people's behavior, actually about the physical characteristics of an object. So that's data that's going to take some expertise to learn, but that's the direction things are going to head. So be prepared for that, and that's where the shifts always come. You don't typically get shifts from new ways to do AI or new modeling techniques, as you might say, as a data scientist. Maybe the new modeling techniques were needed because of new types of data, but the tectonic shifts come from new data being used. And right now, I suspect regulators are going to be demanding a shift in how the industry thinks about data. So, this is a prime time to be leveraging data and to be building AI based on that data, because there's going to be a lot of work to do. And then the other thing, is the insurtechs. So they would like to displace insurance companies. Some of them are partnering with insurance companies. And I used to have logos on the slide, but I decided to not put them there. I don't really want to cause any controversy. They want to out-innovate large financial institutions that they think of as stodgy. Well, that's not going to be easy, in the sense that insurance companies have lots of data that's really required to understand what's going to happen next. And the insurtechs have to figure out how they're going to get that data, if they're going to have enough data to analyze to outcompete the insurance companies. On the other hand, that's for understanding the risk. On the marketing side, the insurtechs understand a lot more. So what do you do when you understand marketing, but you don't really necessarily have the data on the risk? Well, if you have deep pockets, you go buy some data. And, it's clear insurance companies do that too. I mean, 20 years ago, there really wasn't cyber insurance, right? The people who first wrote cyber insurance, the companies that wrote it first, didn't know how much it was going to cost, didn't know whether they were going to make or lose money, figured they were probably going to lose some money, but they were going to learn a lot. You learn a lot, and then you can compete in the marketplace and others can't. Well, insurtechs can do that too. So they are going to have a seat at the table, and they're going to force everyone to innovate. So this isn't a situation where being in an old stodgy industry will protect you from innovation forever. The innovation is coming. So what are some of the key opportunities to optimize operations at an insurance company using artificial intelligence and machine learning? Well, I mean, I think many actuaries would think in the first place of underwriting and pricing, and certainly that's true. That's not just in terms of creating rating plans, but for example, in commercial insurance, you can think about you get way more submissions at many companies than from agents than you can possibly produce quotes on. The quote process still takes time for complex risks. So which ones would you prioritize? Which ones are worth your time? Which ones are likely to close? That's something that is, kind of tailor-made for predictive models, because by definition, this isn't something that a human necessarily has a lot of time to look at. In marketing, where should you spend your advertising money, for example? How do you understand which customers have high lifetime value and which customers don't? And how does that change your engagement with those customers, which is something I'll return to later. In claims handling, there's pretty much every aspect of the claims handling process, and I'll show this on a later slide. You can use automated decision making. Not saying that always replaces human judgment, but it can supplement human judgment. You can have dashboards that give the results of models, give indications of why the model shows something or suggests a particular action, and that can make human decision making better. So it's not always about the machine or the human. In many cases, it's the machine and the human being better than either one by itself. And finally, there's engagement. And it's not just customer engagement and understanding what actions tend to lead to customer churn. It's also how do you engage with employees? What actions tend to lead to employee churn? How do you know when we're all working remotely whether your employees are working? How do you understand without being too creepy that they're actually being productive when they're working from home? So these are all things that you should be thinking about, and in particular, I'd suggest you pay attention to my presentation because maybe your employer knows whether you're engaged or not. So what happens when there are barriers to entry? People try to knock them down. So there's a lot of barriers to entry to writing insurance. You need capital, you need licensing, you need to have a way to distribute the product. For AI, you need some domain knowledge, you need programming skills, and you need deep statistical knowledge. And by domain knowledge, I mean understanding the domain you're applying your AI and ML work to. Well, you can knock down a lot of these barriers. So for writing insurance, instead of getting licensed everywhere, you could write a surplus lines product instead of, which isn't that common. Much more commonly, instead of building your own distribution system, you could leverage the independent agent network, and that's a much faster way to start selling insurance. With AI, there's software tools that are DataRobot and many others that allow you to build AI models without having deep programming skills, that have guardrails in them, so you don't need deep statistical knowledge to build valid models. So all these barriers are being knocked down. It will make it much easier to enter the AI space. Just like writing insurance, pretty much all you need these days is proven after every major catastrophe. Someone right afterwards, someone capitalizes a new reinsurer. It becomes fairly obvious there aren't any other big barriers to entry, and the same thing is going to be true with AI, and it's already to a large extent true. I mean, what you really need is to understand the domain that you're applying the AI to, the processes that you're applying the AI to. That's really the key. But you need to understand it in a specific way that doesn't require understanding programming, doesn't require you having a master's degree in statistics, but does require a certain amount of critical thinking. And those are some of the curveballs that I'll talk about in the second half of the presentation. So this is a slide that doesn't necessarily fit, but I wanted to include it as a reminder that you need to go the full 10 yards to get the first down. So a lot of times people, they do AI for strategic knowledge, which isn't a bad thing in itself, and they just do the first two steps on here. They collect the data, they build models. They say, okay, well, this is what these models tell us. But because in a lot of cases it's hard work to deploy those models in put them into the decision-making process. Hard work, in some cases from a programming perspective, although many tools are making that much easier now. Hard work in the sense that you actually have to convince business partners not just to agree to a platitude about how you should change the company, but actually to agree to change their day-to-day processes. But that's where you're going to get the value. So you need to be able to have those conversations. You need to be able to drive those changes. And then, lastly, you really need to monitor the models over time. And this is, nothing's underlined this like the changes due to coronavirus, but you need to understand, you need to be looking at your models every month to understand, have the inputs changed? If you're looking at telematics, I'm sure you've seen massive changes in the inputs, for example, in terms of how much people are driving, how much they're not. You need to understand, and it's difficult with pricing, but it's much quicker with other models. What's happening to the response? I mean, is the model predicting accurately still, and being able in a position to fix that quickly, rather than slowly if it's not. This is not something that you should be leaving up to a model risk management team that's exists simply for enterprise risk management purposes, that is sort of just a box ticking exercise. This should be an active part of model deployment to make sure that you can correct any issues before the enterprise risk management team even cares about them or knows about them. And finally, this is just no, I shouldn't say finally. Finally, for this half of the presentation, this is just a map of the various, many points in a complex liability claims process where you could, think about a decision based at least in part on a predictive model. So, you have to decide, for example, is there coverage? Is it worth issuing a denial letter? Assuming there's coverage, do you want to assign this to staff counsel or panel counsel, depending on how complex the claim is, or maybe you don't even have any panel counsel that would be appropriate, and you need to retain someone outside of that entire network. You may have a decision, if there's an excess insurer, do you want to tender the claim? And you lose control over the defense, but you're no longer spending money on the defense either. So there's a whole host of decisions in this entire process that can be automated. So some of the curveballs. So over the last quarter century, I've been in software for about half a year, but for a couple dozen years before that, I did insurance. There's a lot of curveballs I've come across, things that are not so technical that you need a data scientist to think about them, but technical enough that you might not think about them naturally if you're not a data scientist. So just things to be wary about. So the big one, and the one I'll probably spend the most time on, or a big one, is missing values. So the trick with missing values is, in a data set, in whatever table your data comes in, I mean, there is a value in that field that is intended to represent that there's no value. But in a lot of cases, that becomes questionable. So for example, if you decide to represent your missing values by writing an NA, well, if that's a field on an insurance application, how do you distinguish between that and the fact that the person who was filling out the application wrote NA? Blank can have the same issue. I mean, if you have a blank for something that's supposed to represent the text from paragraph 2 of a letter, I mean, that could mean several things. It could mean no letter was ever sent. It could mean it was a one paragraph letter. It could mean that paragraph 2 was redacted before you got it because it had personally identifying information in it. Or it could mean that somebody accidentally hit an extra carriage return after the end of paragraph 1, and what would have been paragraph 2 was in the field for paragraph 3. So you need to be a little cautious about what's missing, what does it mean. I apologize, I was talking about Unicode. That should have been UTF codes rather than UCF codes. But what are you going to do with special characters that your system doesn't recognize? And if you have image data, if you have photographs, how do you recognize that it's a blank image, that like you didn't actually get an image versus it just looked blank, but it was the actual image. So those are all things you need to think about. One framework that I like for thinking about missing values, because it forces me to think of all the reasons something might be missing, or the things that people who do surveys for a living think about. So there could be a number of reasons. You couldn't contact the person, they couldn't respond, like they didn't speak the same language you speak, or they refused to respond, they didn't want to tell you. And there's different types of non-responses. They could have just not responded to anything. They could have just not responded to that particular questionnaire in the series of 8 questionnaires that you sent them. That happens a lot in like follow-ups to medical studies where there might be 5 follow-ups and somebody missed one. And there could be item non-response. So somebody may have filled out the entire survey, but they wouldn't tell you their income. Well, the income of people who are unit non-responders and the income of people who are just item non-responders for income, probably a little bit different. So you need to think about the meaning that comes along with different types of missing values. So again, this may be a little bit of beating a dead horse here, but these are just some other examples of other contexts in insurance where missing values come in different flavors. The classic one is someone doesn't have a credit score. Did you just not manage to match them to the data from the credit bureau, or did you match them and they didn't have any data, or did they not? Did they have data but just not enough to create a credit score? Then there are automated imputation methods. The trick there is the right way to impute a missing value and fill it in with something meaningful. It tends to depend a lot on the technique that your data science or statistical technique that you're using to analyze the data. So that's just something to be cautious about. There are different techniques treating it as its own legitimate value, or trying to build a model that predicts what it would have been if you had known it. Which those techniques tend to rely on the idea that the missing values are missing at random, which again is why it's important to understand why it's missing. And the thing about thinking about missing values is just additional legitimate values is then you need to think about the different reasons for missing as maybe different levels of value, not the same. And then the key point here on implementation is that missing doesn't necessarily mean the same thing when you're scoring a model in production that it meant when you were building the model. So a lot of times you need to sort of handcraft the heuristics around that. Classic example is that you get credit data from one credit bureau to build a model, and then but you search all 3 when you implement. So missing was maybe very common and meant one thing in your training data, but when you're implementing the model, it's much less common, but it means something very different. So classic example about how not to how to be careful with interpreting models is you've got high lifetime value customers that you've been able to identify, and you could think about what do you do with that. And a lot of times the tendency is, oh, well, these people are so valuable to our company, we need to do everything we can to keep them happy. But if the reason they're high lifetime value is that they're just very loyal no matter what you do, then you're just wasting money and making them lower lifetime value if you decide you're going to spend lots of money on them. So sometimes you need to understand the reason why. So if you've got a lot of loyal customers, the thing to do is not to spend a lot of money to keep them loyal, it's to find high margin products that they like and sell them more stuff and make more money off them. And that kind of leads into to causation. You really want to understand why something's happening, not just that it's happening. So a classic example would be cross-sell. I mean, you can read the case management and claim example on here, but if you're looking at whether you're going to what you could cross-sell to an auto insurance customer, okay, well, homeowners is something that's often cross-sold to auto insurance customers. But let's break that down. You want to think about situations where you actively make an offer and what's the uptake on that. Not situations where they come to you and say, hey, I just bought a home, I need a homeowner's product. Those are the ones you were going to get anyway. What can you impact? So you need to do some testing around, okay, I'm going to test these offers, I'm going to see what comes back. Not just building a model to say, oh yeah, it turns out that lots of people have auto insurance by homeowners. Yeah, it may be that's the most common next product for them to buy, but the one that you can actually actively sell them on might be a credit protection product. Or if you got people who are homeowners, the thing you could sell them on next might not be auto insurance, it might be a water backup product. So, think about causation and think about controlled experiments and business experiments when you're doing your machine learning and data science. I think I covered this pretty well. Oh yeah, with price elasticity, another thing you need to be careful about is that if you're looking back at past rate changes and the rate change wasn't flat, it usually is a very bad experiment for measuring price elasticity, because a lot of times there's correlations between how big a rate change someone got and maybe how sticky they are long run. There's also tends to be a correlation, if you had some people getting an increase and some people getting a decrease, the people who are getting a decrease, all other things being equal, you were probably charging them too much before. You might still be charging them too much afterwards, so you don't necessarily see the same improvements in retention from a big decrease when it's just for a segment of the book than you would if you just flat gave everybody a decrease or assigned that decrease randomly. So there's you need to be very careful when you're doing price sensitivity studies with sort of differential rate changes like that. That's where you either need a flat rate change, everyone's treated the same, or you need some randomization of assignment. And then I want to talk a little bit about what the word bias means. That tends to be a dividing, sort of a two groups being divided by a common language. In general use, something that tends to unfairly disadvantage a particular group. In statistics, it's just something that won't, in the long run, average out to the value being estimated. In statistics, in particular in AI, that's often used to say, okay, well, we've got all these estimates for these different groups of customers, let's say for their price, but they're not based on that much data. We're going to kind of shrink that back towards the global average because we're not that sure. That's technically a biased estimate. People in machine learning often call it a biased model, but what they really mean is not that they're trying to discriminate against anyone. The bias is actually bringing everything back towards the common mean. So, you get the kind of conundrum that what's biased from one perspective is unbiased from the other perspective, and vice versa. So we need to be careful about how we use words sometimes and make sure that our audience is thinking the same thing we are. And finally, why? A lot of times the answer from a data scientist is, do you care? But really you often care. You need to understand whether what you did will generalize to the future. You need to understand whether you'll disadvantage certain groups. You need to understand because it helps you troubleshoot obvious mistakes. And you need to understand because a lot of models aren't used for automated decision making. They're used to supplement human decisions. So the person making the decision needs to know, for example, okay, this is the suggested price for business owners insurance for this gymnasium. By the way, did it take into account that they have trampolines? Kind of important thing to know. So that's why you definitely want models to be interpretable and to build tools to make sure that you actually understand what's going on and that it's not a complete black box. So one last slide here that I'll just leave up on the enablers of the intelligence revolution and making sure the entire organization understands AI, making sure you have some elite data scientists, and making sure you're empowering lots of other folks to build data science models, and making sure you have a transformation strategy that encompasses the entire organization so that you not only build models, but you get them into production, you get routine feedback on them, et cetera. And with that, I think I'm a couple minutes over, but I think we have some time for Q&A still.
Yes, we do. Let me go over the first question, Chris, which is, right here. Our organization is lately driven by acquisitions, and we're now in a painful data mapping exercise. This often leads to business partners holding off on AI and ML efforts until all the data mapping and cleansing is done. Any ideas on how to overcome this vicious cycle?
Well, I think there's two ideas. I mean, one is you get a lot more than half the value out of half the data. So it's not perfect, but yeah, I would try to build models with the data that I have access to. I mean, that's kind of the cheap answer. The other answer, which I think is more the way the world is headed, is we need to be looking at other ways to acquire data. For example, getting data on customers through the underwriting process is not the wave of the future anyway. Getting more and more of that data through third parties and putting less and less of the onus on the process at the point of sale probably provides you with more accurate information on the customers and makes it easier for agents to do business with you. So, yeah, thinking about the underwriting cycle, that looking for those externals, using this as a push to look for those external sources and maybe get ahead of your competition in that respect, rather than sort of the backwards look. This is the way 8 different organizations collected data in the past. I think is really critical, and especially when you think about implementation, you probably don't want those in 8 different systems going forward. But what's the carrot on the end of the stick to get them to join whatever the excited about the new process that you'll use for underwriting, for example? If the carrot on the end of the stick is you've already got all this AI built, and as soon as you're on the new system, you can use it. That's a lot more exciting.
Mm-hmm. Thank you. Yeah. So question number 2. Most of the AI models are built by neural network modeling, and they do not explain the relationship between predictor variables and response variable. How can we improve the understanding of the relationship between predictor variables and response variable in machine learning?
Yeah, I think there's a number of ways. I mean, almost all tools will give you variable importance using, for example, a permutation method or SHAP. That's critical. Obviously, that's not enough. Partial dependence plots are also critical. They're also obviously not enough. ICE plots, or looking at if you chose a bunch of different fixed observations and just varied one variable at a time, what sort of the prediction path would trace out, and doing that for a bunch of different examples is another. So those are all critical things to understanding what a model is doing with a variable. But the simplest thing, I think, and something that also reduces the cost of implementation, is if you're wondering whether you need a particular variable that's maybe not so convenient or has explainability issues, turn it off. Rebuild the model without that feature, and see if you have any loss in performance. At the end of the day, no one is served by having a model with 200 variables. You can't explain it to regulators. You can't explain it to the business. And to the extent that you're now relying on the world's more and more relying on external data and vendors of that data. 200 data elements is a lot more vendors that you're beholden to. So you maybe want to investigate 200 variables, but you probably want as few variables in the model as you need.
Thank you, Chris. Okay, there's another. We have actually 2 more questions. So first one, great presentation. What's your view on using external data sources to expand the scope and drive up model productivity? Are there any specific do's and don'ts?
Yeah, so I mean, one thing to make sure you understand is the relationship with the data source. if you're licensing it, what are the terms so that you don't have any problems if you decide to end the relationship? If you're not licensing it, like if it's government data, you probably want to do some assessment of, is this something the government is going to continue to produce? I know I forgot offhand exactly what they were, but there were certainly sources of data that the federal government published under previous administrations that have been somewhat curtailed more recently. So, I mean, if you had models that were dependent on that, that was, inconvenient, shall we say. So that would be the main thing is understand the relationship with that vendor. And I guess the other thing is, as data scientists and analytics people, there's a tendency to focus on acquiring data maybe statically to do a proof of concept, to build a model. You also want to understand, especially for data for underwriting, how you're going to get at that data dynamically at the point of sale. So if you need a 10-second response time because this has to happen while an agent's on the phone with an underwriter, well, doesn't do you much good after a few months of finding that this is exactly the right data element if the vendor can't provide it to you like that.
Mm-hmm. Thank you, Chris. I guess another question is, and I think this is the last one. In banking, ML is used mostly in marketing and fraud and rarely used in credit decision. In insurance, what functions are popular with ML and off-limit or rarely used?
Yeah, I would say in banking, there are regulatory reasons in terms of model risk management that they want even more transparency for, let's say, their credit models than even are required for pricing models in insurance. In insurance, certainly marketing and fraud models, you can generally use whatever ML you want. Pretty much the same with claims decisioning models. The limits really are, pricing is a little bit different. Some regulators want a certain amount of transparency, but so personal lines pricing may need to be very transparent. You get into pricing large commercial lines, excess insurance, and things like that, and the regulators don't care anywhere near as much about transparency. But the key thing in most insurance companies is transparency with your business partners. So, insurance is a complex business. Just because you're a data scientist and you built a model that validates really, really well, doesn't mean that the person who owns the profits and loss for that business is going to trust that it will continue to perform well next year or the year after. That person's going to want some understanding of what's going on inside that model to feel comfortable that it's actually going to generalize, that it really works. And that's the other reason I'd say it's, you're usually better off with a model with 10 or 20 variables than 200. And ideally, they're not too many new discoveries in there. Ideally, you want, your business partners will feel a lot more comfortable if most of the variables in the model are ones that they aren't surprised to see there, and that you can give them good reasons for the ones that are surprising and show that you did your homework validating that they really belong there.
Awesome. All right. Well, Chris, thank you so much for such an insightful session. And to the members of our audience, I'm sure that if you have further questions, Chris will be happy to connect on LinkedIn.
Absolutely.
Of course, thank you to DataRobot for their support of this event and many others at Corinium. It's always a pleasure to work with all of you.